In this video, I'm going to show you how you can calculate moles in a mole, meaning we would use the ratio of the part of a formula to the whole formula. Here's a visual of that. So we could have one formula unit of lead 4 chloride. It would have a lead plus 4 ion, and then it would have to have 4 chloride ions associated with it. So for every one formula unit, there would be 4 chloride ions. Well, if I had 10 formula units, then now I have 10 lead ions, but for every one of those lead ions, I had to have 4 chloride ions. So if there's 4 chloride ions for every one formula unit, then if I had 10 formula units, then I would have 40 chloride ions. If we scaled it up again to if I had 100 formula units of lead 4 chloride, that's 100 ions of lead, but then there would be 4 times as many chloride ions, because for every one of these there were 4. So there were 400 chloride ions in this sample. So what if I scaled it up to Avogadro's number, and imagine that this was actually 6.022 times 10 to the 23rd formula units of lead 4 chloride. Well, there would be 6.022 times 10 to the 23rd lead ions, but then there would be 4 times as many of those chloride ions. Well, that amount of formula units is 1 mole. So if I have 1 mole of lead 4 chloride, then I have 1 mole of lead plus 4 ions, and I have 4 moles of chloride ions. So within that 1 mole of lead 4 chloride, there were 4 moles of chloride ions. And that's how we can calculate moles in a mole. We can turn that into like a conversion factor fraction. So if a problem said how many chloride ions are in 1.45 times 10 to the negative 2 moles of lead 4 chloride, well, for every 1 mole of lead chloride, there were 4 moles of chloride ions. And then this one's asking for the actual ions, so then next, if we continue down here, because I ran out of room, so for every 1 mole of chloride ions, there are actually 6.022 times 10 to the 23rd ions of chloride ions. So then I've set it up so that the moles of lead chloride cancel out, the moles of chloride cancel out, and the units I'll have left would be ions of chloride. So then I would pop up my calculator, let's find my cool calculator, and I would turn it on. So this would be 1.45 times 10 to the negative second, and then I would multiply that times 4 since that's in the top, and then I would also multiply it by 6.022 times 10 to the 23rd. Let me just double check that all that clicked correctly. Okay, so my calculator gives me 3 point blah, blah, blah. Well, I can have 3 significant figures, so I'm going to keep 3.49 times 10, and my calculator went away, to the 22nd, and that would be ions of chloride. So we calculate moles in a mole if I need to break a formula down into its components, but I would still use Avogadro's number if I wanted to know the actual number of those particles and not just the number of moles of those particles.